So how you all doing? Wow. This is a lot different than Finland. I know a lot of you weren't there because I heard that, but many of us were there, and I'll tell you it was a little bit colder, like a lot colder. All right, so one of the things I wanted to talk about today with all y'all, and I have the honor of introducing all the different speakers. There's some really good talks coming up. I'm going to kick things off, then we've got a couple other speakers. We've got Minko is going to come up and talk about some things with Angular. We've got Christian to talk about Angular material a little bit, and we've got a surprise talk towards the end of the keynote, which I think you're really going to like. But to kick things off here, first, I wanted to just talk a little about a talk that I've done many times is how you can take Node applications and deploy them to the cloud. I do a lot of Node and JavaScript development. I'll bet you a lot of you do as well. I do a lot of Angular and JavaScript. I like full stack. And the problem with Node or ASP.NET or Java or Go or any of these backend technologies is not so much a problem as it gets into a cost issue a lot of times or a server maintenance issue. A lot of times we have to build an application and we may not have a large backend infrastructure. We just need a couple of APIs. We might need a dozen of them. And we don't necessarily want to invest in a virtual machine or into Docker or into big server infrastructure, even in the cloud, to handle our backends. Sometimes we just want the app to run. Have you ever just done ng new, my new app, and you just wanted to put it in the cloud? Just right away. That's kind of what I want to talk about today. I call these serverless apps. There's a lot of names out there in industry for them now, but it's about having apps with less servers that we can deal with. So today, let's talk about a little bit about serverless apps and what you can do with them. Do you always need servers all the time? Well, yeah, there's always a server somewhere, but do you need a full server infrastructure for every single application? I bet you don't in every situation. I've done a lot of these in my life where I've had big infrastructures in the back end, and sometimes I wish I had something like serverless. And it doesn't necessarily mean that you don't have servers. Like, there are still servers in the cloud, right? We talk about the cloud like it's a magical place, and maybe it is if you're drinking, I don't know. But the cloud is just a place to put our servers so we don't have to worry about them. Serverless to me just means you think about servers less often. That's it. Serverless is a way to make things easier. It's a way to think about the infrastructure in the back end less than we normally do. Now, why would you want to host your Angular app in serverless without having a big infrastructure back end? There's a couple of big reasons. A traditional server, you're going to have to handle security patches all the time. You have to deal with maintenance. You have to worry about somebody hacking your system. We always have to worry about these things. Or if we don't, at least our security teams do. So with serverless, there's less to worry about. It doesn't mean it's perfect, but there's less to worry about because somebody else is managing a lot of that for us. We're just putting the code up there. We don't have to worry about the back-end infrastructure to do that. High performance. Serverless is really great because it allows you to get wicked fast performance, and you can scale up and scale down as you need. So your performance is really, really good. You don't have to worry about how many cores you have in most cases. High scalability. You need to scale up for certain high periods of time. Serverless can do that for you. You can get a plan with your favorite cloud provider that scales up to handle as many users as you need, or scale back down to 0 when you don't need anybody hitting it at the time. Unlike a traditional server, which you need to have running all the time. And low cost. I like free. Free is good. Guess how much serverless costs in general, all these cloud providers, if you don't run it, if nobody's hitting it? Nothing. Which is really cool. So if nobody's hitting it, it's not costing you anything. It only costs when you're actually using it. So to me, this is great. I'm like, I just want to write code. I don't have to worry about these things. So this is the idea behind doing serverless applications. Now, there's a term out there called the Jamstack that's been touted for a while. And I think the founder of Netlify, I believe, is the one who coined this. And it's a cool term. And it kind of applies to the same topic, so I wanted to bring this in. And if you haven't heard this term, what it really means, it talks about JavaScript, APIs, and markup. So what you're really looking at here is you've got JavaScript. We have Angular. We have our APIs. We have some kind of third-party backend, maybe we call, or we have our own APIs in serverless functions that we use. And then markup, which of course we have with our applications. You put those three things together, and you've got your application. Now, I don't necessarily like calling it the Jamstack. It feels kind of weird to me. So I just call these things serverless apps. And there's other things that go with them as well. And we'll look at some of those pieces in there too. But this is an Angular talk. It's an Angular conference. And I wanted to share what this could look like for Angular developers, for all of you, and how cool this could be. And today I'm going to show you a demo that shows you how you can do serverless without actually going to the cloud as well. So you can run it locally, even if you're on like poor Wi-Fi or no Wi-Fi as well. So the way this app might look, traditionally we build applications that look like this. You've got a web browser, that's our Angular apps. You have a web server, something to serve it. It could be Node, it could be Nginx, it could be ASP.NET, whatever you like. You also have an app server in a lot of cases for your business logic, and maybe you're hitting a database. And we've been doing this for about 2 decades before we got away from the traditional two-tier client-server apps. Now, we can do something like this with serverless applications. We have a web browser, and then our APIs could be our own APIs, or they could be third-party APIs. And then we host our app in some kind of static site hosting, in like an S3 or Azure storage, some kind of blob storage out there, whatever you want to host it in, which effectively makes it really cheap because it's just file storage in the cloud. So think of it like putting a CDN on top of it as well. So our architecture might look something like this if you take a deeper dive into it. We have that web browser, and our serverless API could, in fact, run our functions. They run themselves, and they run against some database that we might have still through serverless functions in the cloud. We can use TypeScript or JavaScript to write them. I'm going to show you TypeScript to do that. And then we could have our application running out of storage. And that's where our Angular app is hosted. And then to put the two together, we have plenty of options. The simplest of which is Azure Functions with a proxy. It's like a reverse proxy that the functions can run to connect the two, the serverless site and the static site. Because we need that because they run on 2 different ports. We could also use cores, that's another option. And we could also run something like just a plain old reverse proxy software or hardware tool that we want to do in the cloud. But the easiest way to do it is Azure Functions, and that's what I'm going to show you here today. So the first demo, we're going to look at using Angular. We're going to look at putting the application in storage so we can actually host that app, and then using serverless functions to run our API. And we're going to do this inside of my favorite tool, Visual Studio Code. All right, so here is the application running in Visual Studio Code. Let me zoom in a little so you can see what's going on the left-hand side. Over here on the left, you can see the application. I've got my Azure Functions are right here. Those are functions that I can run from my API itself. My Angular app is in the source folder. We all know what Angular looks like inside of there. Now, when I started this application, one thing I want to show first is I had a Node server running this app. So this is fascinating to me. Let me close down the code here. Inside the Node application, what I had before was just a basic index server here, where I start up my server. I've got things running over here for my services. I had my heroes code. It's all tour heroes. And my heroes would go out and hit a database using Node Express, and everything's having a good old time. But what I wanted to do was get off of Node Express because I was basically running the Node Express server, and it was costing me money to have a service in the cloud to do all of this. And really all I was doing was setting up my APIs to talk to my database. So what I did is I copied literally everything in this services folder over here, which is where I have my models for my data. I've got my services that make my routes for my Express calls, and everything's set up. So like here's my routes themselves to actually call the service. Everything was set up over here. I literally copied that code over into an Azure function. So this server code is actually not being used. What's being used instead is over here in the functions side. I've got all these functions, and I blew them up into individual folders just to show you what's over here first. So I copied those out to the individual folders for heroes deleting and inserting and getting, and also my villains over here. And then inside my shared folder, that's where I put my hero service. This is the same thing I had in my Node code. And the only difference in this code from what was in Node is I had to comment out this line because I'm not using Express in the cloud. I'm not using that for response and request. Instead, I had this context from Azure Functions. So I pulled in that library, and then down below, I just called the same code I had before. It's my same get heroes. I pass in request and response, and then I do my magic with the database, and I return out the code. All this is exactly the same other than that first line. And then I've got my models, same code I had before with TypeScript. I've got my barrels that we use with index files quite a bit. And even my config to talk to my database is the same between both applications. This was literally about a 30-second port from Node over to Azure Functions because I was able to copy it over and just remove or replace request response from Express with the Azure Functions from Node, which of course I did a npm install to get. So once I have these, then I've got these pieces here on the left which show me how to get to the routes. So in Azure Functions, you get a folder here for every function that you have. I've got an API route called heroes get, and then there's a function JSON. And what I do is I rename that route, because I don't want it to be my API/heroes-get. I want it to be my API/heroes. So I renamed that route right here inside of the JSON file. And then my code for the route is very simple. And this gets generated for you. It's using TypeScript. It's an HTTP trigger, so it gets triggered when HTTP calls get made. And then we're passing in the context. We get the request and response objects. And I'm using async await to say, go call that hero service get heroes. I put all the other logic in that other file because I literally copied it from Node over to serverless. So now all I have to do is say await that function call I already had. So the only line of code I wrote was line 8 right here. That's it. And what did I do for all the other calls? Like a post? You probably didn't even see the difference. Look at that. The only thing that changes is line 8 again. And I go down to the put, and it's just a put. So all this is really easy to do. And if I want to generate a new function, all I have to do is I can go over to this little icon on the left. That's the Azure icon. There's an extension for VS Code that does this. And I can right-click inside of the function. And I've got all these great features here, like I can start the app, deploy the function app. Up here on these buttons up there, I can create, if I get the tooltip to show up, create a function is what this one does with the lightning bolt, or create a new project for functions here. So when you click this lightning bolt, it creates a new function, and it creates that JSON file and that TypeScript file for you. And it'll prompt you, do you want to create them in TypeScript, JavaScript, C#, whatever your favorite language happens to be up in the cloud. I figured TypeScript because, hey, we're Angular developers. Why not? All right, so the key here is I've got a Functions app now, and I've got an Angular app. How do I make the two run together? Because those things run separately, right? Well, here's our Angular app down below, and I've got things like my heroes component. What I want to do is show you some pretty cool stuff in VS Code with this. I can set a breakpoint every time I get heroes inside my Angular app. And if I open up another window here, I can set a breakpoint on the right-hand side in my function. So what I want to do is I want to debug both my Angular app and my function at the same time inside the same editor. Basic client and server, effectively, all at once. And to do this, I can click on the little debugger icon on the left, which comes with VS Code. And then I've got these things called configurations up here in this drop-down list. And I've set one up called Angular Functions. Let's go look at that for a minute. So if I look on that file, let's make that go away. You can get these by clicking on this big blue button in the bottom right-hand corner. One of them is attaching Node to functions. We're not going to be debugging Node, but it gives you that out of the box. You can create one for launching Angular. If you don't have this, if you download my snippets, which I'll show you the link for at the end, all you have to do is take a dash, and if you want to launch it in Chrome or the new browser Edge that actually runs on Mac, which is cool, in Chromium, you just click on that button, and it will generate this launch Angular task for you, which by default will have port 4200, and you can change that, obviously. The one below it here is to launch a relative file that I'm in, if I want to do that. And then finally, I want to run Angular and the functions at the same time. So what I do is I create something called a compound. A compound means take two debugging lines and run them both at the same time. So let's make this work. So if I go back to my debugger, and I open up Angular Functions, and I click Run, notice it's now opening up different windows here. It's building the Angular application. It's building the Functions application with the cool ASCII art. And then when it's done, it's going to launch these in the local browser. And it shows me all the APIs that the functions are running. There's the running application. And notice we stopped on a breakpoint. Right here is the Angular app that we stopped at because it's about to load my heroes, which haven't loaded yet. and it says paused in VS Code. If I open up a second window over here, I can then show there's the breakpoint for the Azure Functions. Not about you, but I get depressed when I see that empty gray circle. It's like, oh man, my breakpoint didn't work. What happened? Source maps aren't working. How can I fix it? What that actually means is that you can only have one debug context at a time. Notice in the upper right, I've got launch Angular selected. That's because that's where the breakpoint stopped first. I can also select this one, and then my breakpoint over here becomes red. But I don't have to do that. It'll automatically work. Watch what happens now as I hover over. I can look at the values. I can walk through it, or I can just press continue. And when it continues, it also then gets kicked over to the serverless side and debugs on that side as well. And we're running this all locally on our machines using the debugger in VS Code. Now when you're done, your application's up and running. If you want to see the debug again, you just click the refresh. You can walk through here, and it's pretty simple to do. When you're done, you disconnect both debuggers, and that's all you have to do for it. When you're ready to go to the cloud, you just go over to the Azure extension over here, and then I can right-click, and you can click this up arrow button that looks like it hits a ceiling. That's actually the cloud, I guess. And that will deploy the application up into the cloud. And you can do the same thing with the storage app. For storage, you just, again, click on this blue button for storage, and that'll deploy the Angular app up to the cloud. It's just going to ask you a question about what's the name of the thing you want to deploy it to. And it's also going to ask you the folder of where your Angular app is located, in case it's in a different location than the dist folder. All right. So we just saw how we could use Angular and storage together and run it all locally and debug it with the tools that we have. I wanted to show you some links how you can get there. The debugging piece is really easy to do, which is nice. Out of the box, we can debug Angular, debug serverless functions, do them both together, and create APIs, and then deploy them to the cloud. So the big tips here I'd like to leave you with is try this out. Try Angular in storage in the cloud. Really cheap, really easy, really fast to run your sites. And you might see a little more of this today in a couple other sessions. You can host your APIs in serverless as well, and then put those two together. And if you want to get and try any of this yourself, click on these links here. The first three are how you can get to a tutorial to do the static and the functions, and then using the VS Code extensions I showed. And the last one is the repo in GitHub of this exact project. So you can download it and try it locally, and everything you need is in that README file to walk you through doing it for yourself. So definitely give that a shot. Take a picture. I'll post this on Twitter later today too. #NGVikings. And thank you very much for coming up here.